Hello and welcome to this course on MCP, the Model Context Protocol. Now, if you've been following the AI space, you probably heard people talking about MCP. But most tutorials out there either stay super high level or just throw code at you. That's not what we are doing here. This course is different because we're going to understand how MCP really works and then build something real with it. And here is what it makes this really valuable. We will cover the theory part first, and then we get to know the architecture, the transport layer, the core primitives, and then we will build something really useful for an imaginary company called Technova, so a use case that I set up just for you, where you see how tools, resources and prompts working together to solve a real problem. And we're not stopping there. I will show you how to test everything locally with the help of the MCP inspector and also with the custom client that I provide to you, because all the code that you see, all the slides are free to use and open source. And at the end of the course, we will deploy our MCP server to Google Cloud with the help of Docker, so that you have a good understanding from the beginning, from the theory part, then building our own server and finally deploy to make it accessible for everyone. And I hope you enjoy, and now let's get started. Let's get started with the motivation behind MCP. So large language models excel at general purposes like text summarization, content generation, and natural language understanding. But these models are only as good as the context that we provide to them. Let's have a view here of this example. So we are a support agent and we ask the large language model, who are our at-risk customers this month? And then without this knowledge, the answer is, I don't have access to your CRM system or customer data. But if we somehow achieve to bring this custom knowledge into the large language model, then we have a pretty good answer. For example here, based on your Salesforce CRM data, 5 enterprise customers are at risk this month, and so on. So, and the question is how we bring now this context or this custom data into our large language model. And everyone is therefore steering up their own pot. So everyone is coming up with their own solution, and therefore we have custom implementation, we have custom prompt logic, custom tool calls, custom data access. So we have a fragmented AI development world there. While company A would do this in a really good way and have a security issue, company C would totally over-engineer this solution. And yeah, we have a fragment AI development world in here. And there comes now model constructs, model context protocol into play. Here, so MCP is an open protocol that standardizes how applications provide context to large language models. And think of MCP like a USB-C port for AI applications. So MCP provides a standardized way to connect AI models to different data sources and tools. So let's have a look here where we have an MCP compatible application, and then we use the Notion MCP server to get the Notion data. We use our MongoDB MCP server to also get some data from MongoDB, and then we have a dedicated MCP server for our version control. And what's really nice here is you see we have a separation of concerns. So we have a dedicated MCP server that is responsible for one data source. And what is also really nice is we can reuse the MCP server. So for example, here we have only one Google Drive MCP server, and this Google Drive MCP server can be used by different AI agents and to get the data from Google Drive. So why should you care about MCP? Well, as we know, LLMs need frequently integrate data and tools to be really powerful. And MCP provides a lot of benefits. So here we have pre-built integrations, we have vendor flexibility, security best practices, universal standard, and also reduces duplicate work, future-proof development, and we have a clear separation of concerns. So this was now quite theoretical. I guess the best way to end this section is showing you a real MCP server. And I will show you this here of the example with my own Notion. So I hope you are familiar with Notion, but basically you can use Notion as a good way of organize your content and task. And here you see my Kanban board where I organize my content. And here we see now the Notion MCP server here on GitHub, how to set it up and how to use it. And the cool part is this MCP server were built by Notion itself. So you see this is the official Notion MCP server. And I simply use this pre-built MCP server to get my data from Notion. The other way without MCP would that I needed to first craft my own application, get the access token, and also write down the APIs. So I have done there a custom implementation to get then my data and feed it into the large language model. And so I can simply set up this MCP server and then consume my own data. So how does it look like here? If I now go to Cloud Desktop, if we click here to search on this icon, here we can see the official integrations, and down here we can see our MCP servers that we have integrated. You see I have quite some few, and also one is the Notion API. And if we click on here, we see a lot of things that this MCP server can do for us. So get user, database query, search, and so on. And I've asked here on my Notion page, show me please all topics that I need to research. So if I hover back here to my Kanban board, and we see here on the research topic, it's for example Google UI AI, we see MCP course, Versal AI SDK, Open Nutrition MCP, and then there was a lot of thinking phase here. And now here we have the results. So really the things that were listed there, Open Nutrition MCP, Google UI. And now I could further work with this knowledge. For example, also set up an email and so on. So this is really powerful, and I'm really excited to show you more about MCP in the upcoming sections. And the next one is where we talk about the architecture and the transport layer. Thank you for watching, and then see you right there. So let's get started with the core architecture of MCP. And I would like to start here on the right side with our business domain. And if we think again what MCP is there for, so to bring outside knowledge into the context of a large language model in a standardized good way, right? And if we think about our organization, there's knowledge stored in databases and files. We also have functionality. And Anthropic came up with these three primitives, tool, resources, and prompts that helps us to organize all this knowledge. So let's go through them. Tools are model controlled, and tools are basically functions that are being invoked by the model. And functions, you can think of any functionality that you just write as a software developer, and this can be anything, API calls, database searches, and so on. And the most important part here is to know that these are model controlled, meaning a model decides to call your tool or not. Therefore, it's really important, and we also see this later, that we have a good description of our tool and also the parameter description. Great, so we have tools that can handle all the functionality. Then let's move on to resources. And resources are data, static or dynamic, and this is exposed to the application. So if we have any kind of data, PDF files, text data, audio files, images, binary data, you name it. So any kind of data, either static or dynamic, we use resources. And resources are application controlled, meaning the application decides when to use a resource or not. And in our case, we will explicitly select resources, but there are of course other applications based on heuristic or other smart functionality that picks the resources, for example, by its own. And then finally, we have prompts. And prompts are predefined templates for AI instructions. So if you just give an instruction to a large language model, this is a prompt, okay? And now we can create our own sophisticated prompts and store them on the MCP server so that our users can simply consume these prompts. And the nice part here is that our user don't need to be prompt engineers and also have a good prompt to achieve their goals. And later in the course, we have a dedicated real-life use case where we see this in action, and then hopefully it will get really clear to you what the benefit is. And prompts are user-controlled, meaning the user must explicitly select the prompt to work with. So great, now we have all these primitives, and then we have the MCP server, and the MCP server is there to expose the tools, the resources, and the prompts, okay? It acts like a gateway for these primitives. And then of the other side, of course, we have the MCP Client. And the MCP Client is there to invoke tools, queries for resources, and interpolate prompts. And above there, we have the MCP host that acts like a wrapper. So in the host, or in the MCP application, we can have multiple clients, and each client with a server has a one-to-one connection relationship with a server. So we see here this has a one-to-one with this server, another client has a one-to-one with the other server. And also, what is important to know, the intelligence, so the large language model, lives here on the client side. So this was, again, really theoretical. I guess it's also beneficial if I show this to you here on Cloud Desktop. And what we've done here recently with the Notion MCP server is that we also used tools. So here in the Notion API, these are all tools that the model decided to use to achieve our goal. Now, this is quite easy to understand. And also I want to show you now the resources. So if we go here to Technova MCP server, that is the MCP server that we will build later on. And here we can now select the app logs. And these are, if we click on this, you see this is a log file that we now as the user could select inside the application. And now we can use this resource to work with. So please analyze this log file. So we see that the MCP server exposed this resource, in this case a log file, and we could now easily work here on the client side and give this information to the large language model. So these are now as an example for resources. And finally, we have also a prompt here. So if we click on this, we can also then specify here an ID and also a time frame. And because from the client, we see we can interpolate prompts. So we have there on the server living a prompt with some placeholder, and now we fill these placeholder from the client. And if we now click on this prompt here, you see the whole prompt. So based on your logs on the customer, and this is the part that we now entered, create a comprehensive issue briefing for the support team. And now we see also the applications that we worked before. And there we just simply use the prompt that was provided to us. And if we now select this, we have then can simply invoke the command on our side with the large language model. So this is just a short overview about the primitives, tools, resources, and prompts. Then we have the server that exposes them, and the other side from the client where we invoke these primitives. And in the next section, we will have a closer look on this one here on the transport layer, and then see you there. So now let's dive deeper into the transport layer in MCP. Think of it as the communication highway between clients and the servers in your MCP application. And it's the system that handles how your messages get from point A to point B, regardless of what those messages contain. And now let's have a closer look on the messages and how they are structured. So MCP uses the JSON RPC2 to define their message structure. And this gives us a consistent, structured way to exchange information. And there are three main message types that you will encounter. First, we have the requests, which are sent when client asks servers to do something. And you can see it here, the structure. First of all, we specify the protocol, so JSON RPC version 2, then we have an ID, the method, and the params that is an object. So the client makes a request, and then the server answers with a response. So this is then the answer back, and the structure is almost the same, but we have then here also a result. There's an object and also an error object. And then also we have your notification. Again, here only JSON RPC, method and params, and we use the notification as a one-way update to make some notifications. And so remember, we use here the JSON RPC, which stands for Remote Procedure Call, and it's a protocol that allows us to basically invoke some procedures that it lives somewhere remote, so from the client to the server, okay? And it uses then JSON to actually define the structure, and it's independent of the transport layer. And now let's have a closer look on the different transport layers that we have here in MCP. Now that we understand how messages are formatted using JSON RPC, let's talk about how these messages actually get delivered between clients and servers. And this is where the transport comes in. And think of the transport as the delivery method, like choosing between email, regular mail, or a phone call. And each has its own strengths depending on what you're trying to accomplish. And MCP gives us 3 main transport options, and I want to walk you through each one so you know when to use what. The first is the standard input-output, and we call this SDDO for short. And this is perfect when you are working locally on your machine. And imagine you're building a command line tool or connecting 2 programs on the same computer. SDDO uses the standard input and output stream that every program has, and it's simple, direct, and really efficient for local communication. Next, we have the server send events, or SSE. And this has been our go-to for remote connections. And it's great when your server needs to push updates to clients. And the way it works is that the server can stream messages to the client, while the client sends requests back using regular HTTP post. And it's been reliable, but it does require managing 2 different communication channels. And there's something new, the streamable HTTP. This just came out in March 25. And it's looking like the future standard, or it's the standard now. Instead of juggling 2 different communication methods, everything goes through one HTTP endpoint, and it's much simpler to implement and manage. And if you're starting a new project, it's probably what you want to use. And the key thing to remember is that regardless of which transport you choose, those JSON RPC messages we just looked at stay exactly the same. And transport is just a delivery method, and the content doesn't change. Now, let's have a look on the communication lifecycle. Great, now let's have a look here on the communication lifecycle. So, in the first part, we have the initialization. The MCP client sends an initialize request, the server responds to that with a response, and finally the client acknowledges by sending a notification, and then the connection is established. Then in the second phase, we have the message exchange. So the client can send a request to the server, but what's also interesting is the server can also send a request to the client. And so they both have a bilateral communication working on, and both of them can also send each other a notification. So then they are just exchanging communication in a very efficient way. And then finally, we have the termination, where either one of them can decide to close the communication by just sending the close command, which will then terminate the connection. And now we will move on to another interesting part, which is called sampling. And it goes through the thing that we now discovered. So it allows MCP servers to request LLM completions through the client. Because as we know from the MCP Architecture slide, the large language model lives on the client side. But with this technique, the server can actually make a request to the client and is requesting some kind of intelligence for its task to achieve. So how does it work? So the server requests an LLM help. So the client reviews this request. Then the LLM generates actually the thing, and the client reviews it again, and then the result is returned to the server. And here we have also the possibility to have a human in the loop design, so we as a human can actually see if we want to accept this or not. And this gives us a lot of control and also privacy. So here we have a real world scenario example. For example, the server has meeting data but needs help creating the summary. Then the server requests LLM assistance via the client, and the client handles them the LLM interaction. and returns the formatted summary, and the user maintains visibility and control. And what is also in the context is the model preferences. So the server can actually also say what model preference that it needs, the system prompts, suggestion, context inclusion options, and also some sampling parameters. So this all is my meaning with request controls that can come from the server to the client when making a sampling call. So, and also an interesting view is that the client or server, this is not a hard differentiation of a physical one, but only a logical one, meaning that MCP client is or can also be a server. And the same component plays a different roles at the different times in the conversation flow. And this means that information can move efficiently between systems without anyone having to rebuild our connection from scratch. So remember this, client server is not a physical one, it's only a logical one. And each client can also be a server. And this is now the last slide here in the transport layer. And in the next section, we will actually go through some MCP discovery mechanism, and then we start building our first MCP server. So let's talk about discovery for a short moment. And I think it's really important, and I decided to make our own section here in the course. And let's think about this scenario. So we have a large language application. And when we give this large language application a problem to solve, then the LLM application needs also to be aware somehow of all its tools and resources that it can use to achieve its goal. And therefore, we need, or MCP has this discovery approach where it then can find all the tools, resources, and prompts available. And it follows the same consistent pattern. So for the tool, it has the endpoint tools list to find all available functions that the large language model can execute. For the resources, we have resource list to find available data sources to read. And for the prompt, available templates for interactions. And the nice thing is it follows the same list pattern for all capabilities. The client asks this by making these list recalls, and then the server responds with all available options. And when an option actually comes new or getting removed, then we can also notify the client about this change. This is also very nice. And I think this is the key advantage that MCP has to give this discovery, and then, that our LM application is aware of all these capabilities. So if we have a look here on our previous example, in the beginning, the large language model would make a call here to the Notion API and then would get all these tools here back. So it has the awareness of post page, patch page, retriever page, and so on. And based off my query, it can actually select the right capability to solve it. If we not have MCP, I would somehow hardcode all these API calls or definitions, and then it make this call, and I would maintain these documentation somehow. But with the discovery pattern, we give it a nice flexible approach to grab all this information, and then the large language model can use it. So I think this is a really important thing to know, and a key advantage if you also talk about people and they say, yeah, MCP is just an additional layer that we don't need. Then maybe point out that the discovery pattern is there, that it solves a real problem. And API and the other protocols as well have their right and own usage, of course. But with the MCP, we give the AI to actually use the APIs and the existing patterns in a nice, convenient way for the large language model. Okay, enough talking for the discovery pattern. Thank you for watching, and now let's get started by building our first MCP server. So it's time that we build our first MCP server, and we will use therefore FastMCP. FastMCP is the SDK for building MCP servers in Python, and it abstracts a lot of hard stuff that we need to do otherwise. So it's a very nice abstraction, and it gives us a good developer experience to build MCP servers. So we will use UV, my favorite package manager, and also the one that is recommended also here from the FastMCP documentation. So please make sure that you visit the installation part of UV and make sure that UV is ready to go. so that we can continue with the setup. Great. So I'm now here in my terminal, and what we will do is we will first create a new project. I will use therefore the command uv init and then MCP force. Okay, before we dive into the FastMCP code, I will show you the raw implementation of an MCP server for our calculate tool. And we see we have 25 lines of code to achieve this. We have this section, the list tools, so for the discovery, where we return all our tools and show basically to the client what we have in the store available. We need to define the name, the description, the inputs giver, in a really detailed format. And then also we have here the call tool endpoint. So when it's actually then coming to the invocation, here we need to first check the name. If it's calculate sum, or if you have multiple tools, then you need to do this with a lot of if else. And then we need to parse the arguments out of it and then finally call it. So we have a lot of things going on for just a simple thing. And now I will show you the easy implementation with FastMCP. There we have then only 7 lines of code, and you see all the hard stuff is hidden away with the tool decorator, because from here with the tool decorator, FastMCP gets the doc string to describe the tool. It's looking here into the arguments nodes from type float and basically can build up the whole schema definition for you under the hood. And now what we need to do is we simply import FastMCP from the FastMCP library. We create the server here by calling it with the name of the server. Then we have here our MCP variable available. And again, this part we've discussed. Now here we create our tool and make it also available as a tool with the help of the MCP tool decorator. And then finally, we check if we're here in the main function and then serving our server with MCP run. So what we now need to do is uv add FastMCP before we even can start the server. Okay, I've already done this, and now we can serve our server with uv run and then hello.py. And we see here our calculator server is up and running with the local SCDO protocol. Great. Okay, so let's stop your MCP server, and now I will show you how we can test out our MCP server. So we will use therefore the MCP inspector, which is an open source tool provided by Anthropic, who developed the MCP protocol. And the inspector is basically a UI that gives us a built-in functionality to connect our server and list all the resources, tools, prompts, and so on. So we have a nice UI to interact with all these primitives on the MCP server, and we can use it with the SDO protocol, with the SSE, and also with the new streamable HTTP protocol. And it's very simple to set it up. We only need to use this command here and then the command to open up or fire up our MCP server locally or on the remote side. And just let me show you what I mean by just applying it. So I copy over just the first part, and then we will go here in our MCP course directory and then followed by exactly the same command that we used before to run our MCP server. So uv run hello.py. And now we see that the inspector is running on this URL here. And if we then click it, we see STOs already pre-filled here. We see the command and also the arguments that we filled in the terminal. And now we can only connect here. And then we see with the green dotted connected that the connection to the server was successful. And we now can list our resources. Surprise, surprise, no resources, also no templates in there. But if we go here to tools, list our tools, we see our calculate sum tool, and we can also then directly try this out here. So let's fill in here these 2 parameters, run the tool, and we see the result. How cool is that? Here we also see the history of all the client calls we made from the inspector. Here, for example, we made a discovery to a call to list all the tools. We got this array back here. Yeah, and then we also have the tool calls where we actually then call our tool. You see here all the params. It looks quite familiar to the one that I showed you in the raw implementation of the server. So here we fill in all the stuff and then fire it up this command with the help of the inspector. How cool is that? Okay, so now let's move on to the Technova context where we will build the MCP server for Technova to help these guys. So we know that FastMCP is the way to go to build MCP server. We have some knowledge about MCP. Let's apply it to a business context of Technova to help them. And imagine this scenario, angry customer calls the support agent at Technova and is asking about the current state of the problem. And the overwhelming support agent needs to quickly retrieve all the relevant information about the customer and the problem. And usually they do it with some different tools and it's quite time consuming. And we will provide them a nice and easy way by defining a tool where we can pass in just the customer and then retrieve the information about the customer and the current tickets in a given time frame and return it in a nice structured way. And therefore we will use the customer database to actually that the agent writes then a query and then execute it. Sorry, not the agent, but the tool. And here we have then the customer database. Let me show you this so you have a better understanding. It's a really simple SQLite database where we have contacts, customers, subscriptions, and support tickets. So we have the contacts where we have concrete persons and the customer ID, the title, and the email. We have then customers. And so our customer has a contact. And here we have to define the companies for Technova and also the size and the country. And then in support tickets, we use the customer ID, the contact ID, the subject of the problem, the description, the status, the priority, and the created and the resolve date. And that's for the information part that we then need to retrieve. And if we now, let's move over and actually then build this MCP server, I will just paste over my code blocks and we will focus on the MCP parts. I will just give you an overview about the function, but this is a really MCP focus now, okay? This is not about Python. So let's get started. We have already here our FastMCP creation part. We can leave it as it is here. The only thing that we need to adjust is of course the name. So let's call this Technova customer support. And then we define the path to the database. And the database is right here. So in data TechnovaDB. And of course, let me import all the necessary libraries we need for this example. So we use here OS to craft the whole path to this database. And then I store it here in this global variable. Let's also fire up a little helper function to get the DB connection. And then we come to our first helper function. In the context is to retrieve the customer based, and here we need to get and pass in the customer ID. And yeah, here we need use our helper function to establish a connection. And with this connection, we execute the query where we then use the passed in customer ID to retrieve the plan of the customer, the seats, and the subscription information about the customer. Oh, sorry, I guess I showed you not the subscription table. So this description table is like here. We have the customer ID, the plan, the seats, the start date, renewal date, and monthly value. So this is also a very important metric because if this is a higher value customer, we need to resolve, of course, the tickets fast and reliable. And this is exactly what we do then here about when we get the customer. Then we get also another function to retrieve the tickets of a customer where we passed in the customer ID in the time frame, and then we craft again a query to get the tickets based on the customer ID and time frame, and then return it as a dictionary. And then we have also here our nice format support summary. I will show you this in a minute where we will use it, but first of all, let me define our tool that we really expose. So we can now get rid of this example tool, calculate sum, and then we will replace it with the generate support summary. And you see this is the only tool that we mark as a tool, and so expose it. And here, this is the orchestrator main function that uses all the other functions that we defined to get all the context information about the customer. This is what we will then expose to the large language model, and therefore, of course, we need to really describe this here. So here we say generate a concise summary of recent support tickets for a customer. This function is exposed as an SMT tool for a client application, arguments the customer ID, so the unique ID of the customer. And it's very good that we also expose here some examples, concrete and real examples, and the time frame, look back period for support tickets, 7 days, 30 days, and so on, and the returns formatted summary text with customer and ticket information. As I've told you before, it's really important to be really good at this part, because the large language model gets this information and based on this will use your tool or not. And what we will do here is we first get the customer based on the customer ID, then we get the support tickets, and then we nicely return all the information with the format support summary that we defined previously. So we throw a lot of different context information into this format support summary, and it just brings it back in a nice format. So you see the customer information here, the size, the industry, renewal date, subscription status, and the ticket statistics, support summaries, open tickets, total tickets, high critical, and so on, and the individual ticket details in detail. And these are the main functionality that we use now. And what's left is, I mean, we could also leave it as the normal STTO here, but I will show you now how to set up the MCP server with the SSE protocol. Therefore, we use here the MCP run and then specify the transport as SSE. The host is our local host and port 8000. And before that, I just have some two printouts. Technova customer MCP server starting, and then to validate the DB path is correct, just printing it out, and then restarting our MCP server. Cool. So I hope you get the idea of this whole functionality, and I guess it will be much clearer if I now show you how to use it. So in there, let's also maybe rename, not to hello, maybe my server. And now let's run it. UP run my server. Great. And now we have an unexpected keyword argument host. This was not working because of this import here. So because if we have a look here on the new documentation, I need to import a MCP like this. And then we should have no problem starting our server. So UB run my server.py. Okay, and you know what? Also let's configure here the log level. So if we specify here log, and the transport layer, I told you not to use the SSE protocol, and I also mean it. Here in this section, I showed you now how to use it with the SSE protocol because I want it to be also backwards compatibility. But make sure that you also use here the streamable HTTP protocol. And if you don't know how to set it up, just have a look here on the FastMCP GitHub repo page or visit the documentation page. And it's very simple. Instead of SSE, just type transport equals streamable HTTP. And then the endpoint is not /SSE, but /MCP. And then you're good to go. And now let's further continue. Okay, so what we now need to do is to define from Claude Desktop how we can reach our MCP server. And open up VS Code or any other editor and open up the Claude Desktop config JSON file. You find it here in your user library action support Claude, and then you find this. And you should find it like this, so only with MCP servers and then an opening object. And what we now need to do, I've prepared this, so let's go over what's happening here. First, we need to define the name of the MCP server. in our case, Technova MCP server. And then we have here the command and arguments. So on a command, it's usually MPX, UVX, UV, or whatsoever to start our MCP server. And then the args is we are using here MCP remote. So this is a service that allows us to connect to remote MCP servers. And we referenced here in the second argument the URL of our MCP server. And this is exactly what we can see here. So on the local host, port 8000, following with the SSE protocol. And just a quick side note, the SSE protocol is going to be deprecated. So make sure that you use the new streamable HTTP protocol if you're dealing with a remote MCP. Great. So with this in place, we have now told Claude Desktop how it should reach our MCP server. And since we're using now SSE and defined it on the local way, but if you deployed now your MCP server, you would specify here, of course, the URL that your server is deployed, and then you can use it in the same way. Great, so with this information in place, we've set it up, and what we now can do is open up here Claude. And then if we open up this icon here, we see now Technova MCP server with our generate support summary tool. And now let's hit up this query. Can you help me prepare for my meeting with ACMeet Corp? The customer ID is ACM001. And now we need to allow this tool call. And we see, based on the current summary, it's experienced multiple critical issues that need immediate action. All 3 open tickets were created on May 4th, suggesting they may be related to a recent system update. Key issues to address, so we have here authentication failure and API integration error. Wow, and Salesforce integration is broken, reported by Sarah Johnson, CTO. Users can't log in after a recent update, reported by Robert Dave, IT director. How cool is that? So you see, we use this tool call to get quickly all the context information we need, and therefore the support agent has clearer information in a shorter time and can now better deal with this incidents here. And in the next section, we will have a look on how we can further extend our MCP server with resources and prompts. So we have now our first tool in place, and now we will extend our MCP server to serve resources. And let's quickly recap what a resource is. If we go here to my architecture picture here, we see that the resource is application controlled, and we serve data, static and dynamic data exposed to the application, and this can be files or database records. And what is this meaning of application controlled? If we have a further look down here in the documentation, we see resources are designed to be application controlled, meaning that the client application can decide how and when they should be used. Different MCP clients may handle resources differently. So for example, Claude Desktop currently requires user to explicitly select resources before they can be used. And other clients might automatically select resources based on heuristic, and some implementations may even allow AI model itself to determine which resources to use. So in our example now, we also will explicitly select them, but just that you know that this is not always the case and depends on your client. So what we will now do is to extend our MCP server by adding resources, and this will give the support agent the opportunity to quickly grab the logs that happens in the workflows. So you see, with the tools, we are covering here this part of dynamically retrieving data from the customer database. And with the resources, we will now capture this part here, where we will grab the logs. So we have in this scenario a system-wide app log that captures all overall system logs. And then we have for each customer a dedicated customer log, for example, here customer underscore ACM001 log that we will then use for our further example use case. So let me show you how we can implement resources on our MCP server, and let's start with the system application logs. So I will copy over now our code block and then we go through it. As with the MCP tools, we have also a decorator for the resources called MCP resource. And the thing that we specify here, it's called a URI, and we need this to identify our resource. And URI stands for Uniform Resource Identifier, and it's a string of characters to identify resources on the internet. And as I mentioned earlier, it could be anything on the resource side, videos, images, binary data, you name it. And we use the URI to uniquely identify these resources. So this is the URI is another standardization, and it's been leveraged by the MCP protocol to uniquely identify resources. We can also use here other parameters as well, provided by FastMCP. But the others are optional. The URI is required. So we can here also give it a name, for example, app logs. This is quite cool. And also a description, so Technova application logs to further enhance the description here. Then followed we have the function that is now handling this resource. It's called getAppLogs and it's returned a simple string. So what we are doing here is quite simple. We open the app log path, we read it with this file reader here, put it into this variable. If nothing in there, we then return this sample text. Otherwise, we craft here together some header information, so the path, the size of the file, and so on. And then we simply combine these two, so the header and the content, and return it. So we've now added this. And now let's use the MCP inspector to see if we now did everything right. And therefore I call the inspector with this command here. So UV run and then the whole path to the server. If you don't know how to get the full path, just right click on your server, copy path, copy paste it then into this terminal call here. Great. And now let's wait. We see, yep, that the inspector correctly open up here on this URL. I've already have this open. Let me refresh this. We choose here the STDO protocol. UV as a command is right. And then here run the whole path to the server. Click on connect. We see we are now connected. And we see the initialize was okay. Now we make a list resource call. So this is the discovery call from our client to see what resources do we have on the server. And we see that we have the app logs available. Cool. And if we click on here, we see then we get here an array and the first entry is our app log resource. Great. So now we have created our first resource. This was quite easy, but now we have a problem. We have multiple different customer logs. So of course we could, for each customer log, define a dedicated resource as we've done it with the app log, but this is not very efficient because every time a new customer comes in or goes out, we need to modify the code, and this is not so nice. So since we have this dynamic part, we need a really reusable and nice solution. And there we can leverage resource templates. So here, these are dynamic resources that the server can expose and the clients can use them to construct valid resource URIs. And let me show you this, how it looks in the implementation. And then I guess we have a better understanding of what is going on and with these dynamic resources. Okay. So again, I will copy over the whole code block and then we will go through it. So beneath the first resource definition, I will paste over here this part of the dynamic one. We see here again the same way with the MCP resource decorator. Then we have here our URI. But what is different here is this dynamic part with this placeholder. You know it for dynamic strings, how you craft them, and it's exactly the same. So you see later on, we need to inject this placeholder with a concrete ID value. And this comes from here. So from the concrete implementation, guest customer logs, this is accepting a customer ID, and this will then use this parameter to fill in this placeholder. Quite easy. And the goal is simple: to serve dynamic content. So what's happening here is not that really spectacular. We have some kind of validation here if the customer ID is valid, and then we craft together our whole customer log path, and it's constructed by the previous log steer. And the log steer, if we scroll up, is just the path to the logs. Okay, and then the second part is then the dynamic part that we craft. So with the injected customer ID, we then use it here to craft our file name for the log. Then we combine these two, and voila, we have our customer log path that we want to serve. And with this path in place, we open it up again with a file reader, read it, store it in a content variable. If it's not, if it's empty, we replace it and then give this placeholder information back. And then also the same as before, we have our header information here, and then we return the header combined with the content together. So, and now let's save this, and again we will restart now our inspector to test this dynamic resource. And if we now refresh this, connect, we see the resources, okay, but in order to test out this dynamic resource, we need to use here these resource templates. So dynamic resource and resource templates is the same name for the whole same concept. Then we need to list here the templates, and then we see we get our function to get customer logs. And here we can now define our customer ID. And of course, this needs to be a valid one. So let me quickly see what we have in here. So we need this path here, this part we need to specify. Now let's provide it, enter, read resource, and we see we get now the content of this customer log file here. And if we also provide a value that is not correct, we should get a error. And yeah, this is quite expected behavior because we have this file not here available. And the cool path is that we see the whole path to this log file, customer_text, is of course not here in this logs folder. So keep in mind the dynamic resource templates is for serving dynamic content, and with the resources here on this part we see the static one. So now in the context of Technova and the customer support agent, I want to show you how we can really then leverage the resources. So I've prepared, before we use Cloud Desktop, but the Cloud Desktop as a client and application is not sufficient enough for showing you these capabilities that MCP can offer to you. And therefore I came up with a custom client implementation to now show you better the resource that we do now, and also in the next section, the prompts to leverage it. So I'm now the customer agent. I've used a previous tool call to get the context information of our customer of ACMM. And what we can now do is, let me now run the client. We can now here access the resources. So I know there's a problem, and now let's have a look here on the logs. If I just specify it here and then under the hook, it just makes this resource get call that we also used with the inspector, and we see now here the whole logs information. But this is quite cool, okay? But what we can now do is, since the intelligence lives on the client side here, we can now further give this information to Claude. So help me understand what is going on here, and then we just simply reference here our system logs. And now we see that we getting the resources from the server, from the MCP server, and then we can dynamically then pass it further down to our large language model. And as you can see it here, we have now a good understanding what is going on with the logs. We see here that OAuth upgrade deployment was done and that the problems then emerge from this upgrade. We see legacy token rejection, expired OAuth tokens, and so on, and the impact. And then we can further enhance this if we then, okay, that's problematic. Here are the customer logs to further analyze this. And then we can use our dynamic prompt to get now the customer logs. So where is it? Here, this one here with this command. And as mentioned before, the resources are controlled, application controlled. So now we explicitly select them. But of course, with this client in place, you could also program it in this way that it's so smart enough to fetch it by its own. And now we see here, since we passed in the customer log information of ACME, that on this date, everything was working correctly. And then Sarah Johnson successfully logged in. Okay, sync was working, and then major issues started. Multiple authentication failures for different users. Sarah, Robert, John. Root cause appears to be an all-off version upgrade. Multiple integration failures. Impact. A response. 3 support tickets were created since then. Yeah, and this appears to be a significant system-wide authentication issue. Now we have used the resources and the dynamic resource parts to further give this information to our large language model as a support agent to quickly resolve this issue. This is now quite powerful. And now we've done some prompt engineering here. We used the content from the resources. We crafted our own prompts. This was quite okay, but the quality of the resolving now depends on the support agent and its prompting engineering skills. And in the next section, we can see how we can leverage prompts to provide a nice baseline to every support agent to have a really good prompt in place so that everyone has the same benefit of resolving the issues in a fast and good way. And it's not depending on the prompting skills of each support agent. So see you in the next section where we then also add our MCP server with the prompts. Okay, so let's tackle prompts. So prompts are predefined templates for AI interactions. And you can imagine it like this. So we craft some commands that then we store on the MCP server, and our users can then select these prompts and then use them to achieve a certain goal. And therefore, prompts are user control, meaning the user explicitly select the prompt they want to use. And in our context of Technova, we've experienced this in the previous episode where the support agent crafts something together to investigate the logs. And this investigating log prompt, we can serve our users. So we define this prompt on our server, and then from the client side, they can interpolate this prompt and then use it because the large language model lives on their side. So we provide the instructions, they can further enhance and fill in these instructions and then execute them on their side. So let's have a look how we can then integrate this into our MCP server. So I will, after the resources part, I will now create here a new section for our prompts. As a comment, MCP prompts, and I will copy over the code block, and then we will go through this code block again to see what is happening. So as you can imagine, we have a dedicated new decorator for defining prompts. It's called MCP prompt. And here we define our prompt with a name. So in this case, customer issue summary, a description, what this prompt does, create a comprehensive customer issue summary from logs and support data. And we can also give it some text, customer summary support. And then beneath there, we have our customer issue summary. So again, the concrete implementation for serving this prompt. We see it takes in a customer ID and a time frame, which has a default value of 24 hours, and it returns a string because, of course, we interpolate this prompt from the client. So from the client side, we provide these information, and then we get back the whole prompt, which is, of course, a string. So what we are doing here in this prompt, so let me just show you the log. So based on the logs on the customer with this ID placeholder, create a comprehensive issue briefing for the support team. We see here the application logs, the customer ID, and then the customer logs. We mark it here end of logs, and then analyze the last time frame and include the technical issues, business impact, and the resolution strategy, and format as a structured briefing document that a senior support agent can quickly understand and act upon. And what is really great, that we can now automatically, based on the customer ID, fetch the customer logs and also put it directly into our prompt, and the same as the app logs. So since these information is also just stored on the MCP server and we have access to it, we can, of course, further enhance this prompt by hiding away this complexity from the user and craft there a really good prompt. So with the logs in place and then with a nice working instruction after that. And how we can do this? Yeah, because since we have specified the customer ID as before, where we crafted the dynamic part, we craft our customer log path. Then we read this customer log path here with the file reader and store it here in customer logs. And the same with app logs, because we know where it's stored on the server on the path side. We read it and store it right into this variable called app logs. I've renamed this, it's called app log path. So let's fix this. And now everything is in place and you understand now what is going on here. So let me now save this, and from the client side, I will now run the client again. And we can now, here with the help section, I can also list first of all the prompts. And we see here the customer issue summary. Nothing special is happening here on the hood. It's the same as we would do it with the MCP inspector. So we make a discovery call, what prompts are there that we can use. And then further, if we have the concrete name and ID, then we can call it. And here we see now, this is the prompt, and these are the ID and the time frame that we can specify. So let's do this. I will now use this prompt customer issue summary. Customer ID is ACM001 and the time frame is 24 hours. And then run this prompt with Claude, and I say yes. And then here we see the result: an incident overview, critical service disruption following the OAuth 2.1 deployment affecting all authentication and integration services. We have here again, as we defined it in the prompt, the technical issues, integration failures, the business impact, and the resolution strategy in place. And yeah, because it's mentioned here with OAuth issue, we can be sure that we've provided the right log context because of the previous episode where we do this manually with the resources. So this is a really nice way to give our users the instructions, the prompts that we crafted from our side, and then so that the user don't need to be a good prompt engineer to achieve their goal. That's it for the prompt section, and see you in the next one. So in the last episode, we added prompts and now finalized our MCP server. Locally, it works perfectly fine, but here's the thing. Our coworker also wants now to use this, and therefore they needed also to copy over the code, install the dependencies, so FastMCP, set up everything. And this is quite heavy. So we need an easy way to make this also accessible for other members in our organization. And therefore, we will deploy our MCP server to Google Cloud with the help of Docker, so that we have run it there on a remote side, and then can set up the clients on our coworkers then, and that everyone can use this fantastic setup. So let's get started. Before we start with the deployment, I would like to go through the whole deployment process together so that we have an understanding why we are doing this, okay? This is really important for me that you understand the concept behind it and not just type the same things as I do in your terminal. And I also want to highlight that the focus here is MCP, and because throughout the deployment process, we will use Docker, but I expect from you that you're already a bit familiar with Docker. I will try my best to explain the concept behind Docker along the process, but the focus here is MCP, okay? So we are here at the moment, and we have our MCP code there and also the installed packages. So in our case, FastMCP, and we can run and enjoy our server locally. But of course, now if a colleague of ours would like to use this, they also needed to copy over the code. They also needed to set up and install the packages. And this is quite heavy. And what we are now doing is we create a Docker image. So this is basically a snapshot of your environment. It's like if we would copy over everything and then close it up, this would be then our Docker image. And we create our Docker image with the help of the Docker file. So the Docker file describes how we can create our snapshot, okay? So it's basically just instructions of, hey, start with this Python base image and then copy over this parts and then open up this port, and then also like in the end, how we can run our server. But we will get there later. So then we have our Docker image, and then we will upload this Docker image to the Google Docker registry. You can think of the registry like a GitHub, but just for Docker images. So we upload it there. There we have a version control, enhanced security, and so on. And of course, there are multiple images there, not only one. And then we will use Google Run to actually then grab this image and then execute this. And when we execute a Docker image, we get a Docker container. So a Docker container is your image, but just executed. And you also see it here, we have here this little play icon in place. And here the pause icon. I just wanted to use this visualization for better understanding there. Once we have this Docker container in place, Google Run will provide us an endpoint URL, and we grab this one and then set it up locally here on our MCP client, and then we will test it if we can enjoy our MCP server on the remote side, as well as we can then do it on the local side, okay? And there are a lot of things that we need to do. For example, also here with the tagging, because this is really important. Because when we say that we would like to execute this Docker image, we first need to also identify it, because we need to say, hey, Google Run, please grab this image and then execute it. And then Google Run would say, okay, but which image do you mean? And therefore we use the technique of tagging. And with tagging is like here. So we say, okay, this Docker image has like this tag of Technova MCP, the name. Then we deploy it. Then we have this information there and we say, okay, Google Run, grab this image with this tag and then execute it. So there are a lot of things that we need to achieve here. And the first thing that we will start now is to create a Google Cloud project and also set up the Google Cloud CLI, because we will use the CLI to orchestrate and drive the whole process. Okay, so let's get started now. So let's get started by installing the Google Cloud CLI. Why do we even need the CLI? So we have it there and then on our terminal, and then we can invoke the commands that will be executed on the remote side of Google to run the whole deployment process. Okay. We could also use, of course, the Google Cloud UI, so the web portal, but I think the CLI approach is much more professional. And therefore, we need the CLI. So here, visit this website, cloud.google.com, SDK docs install, and then follow the instruction for your operating system. If you're on Mac, you could also use Brew. And with Brew, it's so easy. Just copy here the command, go to your terminal, and then paste it over, and then it's been installing for you in an easy way. And what we then also need to do is to create a Google Cloud project. So then just go to Google, type in there Google Cloud, visit the first link, then go here to my console. I've already have an account, so make sure that you log in, create an account. And then what we need to do is we create a new project, and therefore just type in the search here, project, and then we see it here, create a new project. You can also click, if you already have one, select a project. You see you have quite a few here, and then we can also click here on a new project, okay? And now let's name this Technova MCP server. And then no organization, this is fine. Let's create it. Create it now, select a project, and then we are done. Nice. Okay, so we have now created the Google Cloud project. We've installed the CLI. It's time that we now connect. So our terminal, our machine to the remote side. Therefore, open up the terminal, and there we type in gcloud init. And then we see you must sign in to continue. Would you like to sign in? We click yes. Allow. And now choose your Google Cloud account. And then click on continue and then allow. And now we are authenticated with the gcloud CLI. Nice. Then if we move back here, we see all our Google Cloud projects, okay? And so make sure that you select the right project. For me, it's like number 10. As you can see, it's Technova MCP server. I will select this. And now we have configured the Google Cloud to now every command that we invoke, it will be in the context of this project because we've selected it now, okay? So it's really important that you select the right project there. We can also use this command here, Google Cloud config list, and then it would like print out our configuration. And then we also see here are the email address that we use to log in and also our project so that we can validate if everything is correct. So please run this command, check if everything okay, and then we can continue. So before we even can deploy our server, we need to have a look here on the server. If we scroll down here on the MCP run, make sure that you have the following parameters in place. First of all is transport equals streamable HTTP. This is important because SSE, as you know it, is deprecated, and the new better way is to use the streamable HTTP protocol. And also the host is very important because if you don't define a host like this under the hood, what is happening, you have like this setup where host is equals to your local host or your local IP, meaning that only requests from your own machine are accepted. And this is good for local development testing, but if we deploy it, of course, we want to make it accessible for other people. And therefore we need to use another network interface here. And we use this one here. And this means that we are opening up all requests from any IP. And this specify here the zeros, any IP. So we are allowing all requests. And the port, I'm getting here the port information from the environmental variable called port. Otherwise, as a fallback, we use 8080 and then we parse it to an int, then use it. And the log level, just for me, I'm using here debug because then I have more information later on. But of course, you can choose any level you want. So again, 3 things: the transport, make sure it's streamable HTTP, host 000, right? Port must be the same as you defined it here in the Docker file, expose. Very important. Okay, with this information in mind, we can now start by now creating our Docker image. So we are now freezing up our environment, right? And then making it available. And therefore we write docker build -- platform Linux AMD 64. And then we use here /t standing for tag, and then the tag name, so Technova MCP server, followed by a dot, and a dot means where the path is, where the Docker file is. And we need to specify Linux here because I'm on a Mac machine, but later in Google we use a Linux machine, and therefore, of course, we need to build this image for the Google Linux machine. So press enter. For me, it's getting quite fast because it's all cached. And now after that, we can run Docker images to make sure that this image is now was correctly built. So scroll up a little bit. We see it here on the top, latest, created 7 seconds ago, 2 and the size, quite a heavy size, but this is okay. Okay, and now we need to enable some services in Google that we need for the deployment. And the first is that we enable the artifact registry. So invoke this command to actually then enable the artifact registry is the, as I showed you in the whiteboard, it's the registry where we store our Docker images, like GitHub for Docker images. Great, and then we need to do the same for the Google Run API. And no worries, you find all the commands also then in the YouTube description. And also later on, I will show you that this will be then much easier. So, and now with this in place, we can now actually create our repository on the artifacts. So if it's the same, if you would like to create a repository, but on GitHub. So here we say gcloud artifacts repositories create, and then we specify the name, so Technova repo. And the format is for Docker, the location is US Central, and the project is our project that we use. I guess you don't need to specify this project even here because we set it as the default one, but just to make things sure. Now I get an error message that this already exists because it already exists on my side, but you should be fine. Okay, then we have the repository. So first we enabled the services, right? And now we create the repository where we then can store a Docker image. And now we need to authenticate also ourselves for the Docker use. So right in here, gcloud of configure Docker US Central Docker pg key.dev. Then you get there a little, I guess you need to confirm this by typing yes. And now we also need to set up some further roles on Google Cloud. Therefore, we use this command here because with our authenticated user, with your email address, we need to give it the proper role in the IAM to actually then use it correctly. So therefore, we specify here add IAM policy binding, Technova MCP server, member is our email address, and we give it the role of an editor. This is very important. Also, I don't know if this is necessary or not, but we will also grant the artifact registry the writer permission, and therefore we use this one here, so the same, but just with the artifact registry writer role. And now what we need to do is we need to proper tag our Google image for the registry. So, Docker tag with our existing image, then followed by the URL from the registry. Then we have here our project, and then we have here our repo, and then we reference here our local Docker image. And now we have this proper tagging that we can now use for pushing our image to the remote Artifactory repository side. Therefore, we write here docker push and then exactly the same thing that we have defined here. And now, before we actually even do the deployment, let me show you how this looks like on the UI. So therefore, we type here artifact registry, and then we see that we now also have here our repository. Okay, we can click in here, and now once we've pushed this Docker image, we can also then see it here. But you can also, of course, do all the steps that we've done from the CLI also here in the UI, of course. Great. And now we come to the last step where we now deploy our image. So again, here what we're saying, we Google G Cloud Run. So we use the run service that we further also enabled. We use deploy and then the Technova MCP server. And here we tell with the image tag, image flag where the image is, because Google Run grabs this image based on this parameter here. We specify also the region where it should be running. So in our case, US Central. The project again, so our project that we created, we allow unauthenticated requests. We specify the memory, here 1 gig. The platform is managed, and this one is very important, the port. So we are opening up port 8080. This is the same as we exposed from Docker, and is the same that we defined here on our MCP server. Great. Now let's run this command. And at least at this point here, if you not proper set up the IAM rules that we've done before, you would get an error here that you don't have the rights to do this. So therefore, we have done this step before with the IAM setting the writer role and the editor role from our own user that we are logged in, just as a background. So, and now we see that the deployment is there and serving 100% of traffic. Nice. And then also we have here the URL. And if we now also go back here to the Google Cloud, let's search for Cloud Run. And we can see here is our deployed MCP server. Very nice. And then we can switch here to the logs. And it seems everything is working fine. We see here Technova customer MCP starting. We have the path here, the logs, and this is all possible because of the Docker image that we just moved over in the Docker image. Now we are running this image, so we have a container. I would say, let's test it out. So therefore I open up here another terminal. And in here now I've prepared, our client that we have. And here I will now run it. So uv run client.py. And here I've configured the client like this, that we can pass in the URL. And now let's do this. Okay, I will now show you some error cases, because there was a little thing that I forgot during the recording and it drove me almost crazy. And I want to show you this because I think it's important. So we see we cannot connect, and it's because we missed the endpoint, and the endpoint is of course MCP, right? So before it was like with the, if you use the older protocol SSE, it was like this, but now I thought we can use it now like this with MCP, okay? And we see we still cannot connect, because the issue is we also need the final, so the ending slash here on MCP, and then we have the full path available, and then we can finally connect. And so we now successfully connected to our remote server that lives on the Google side. We also had a look here on the logs, and also you can use, of course, the other tabs to get more information, like here on metrics. We can also hear the request count, the latency, and so on. And I also told you that there is also an easier way to use all these commands, because having them in mind is quite heavy, and therefore we make use of the makefile. So the makefile is there to basically have quick access to complex commands. For example, here you see deploy source. If we type make deploy source under the hood, these things will be then invoked. So for example, now I can write make deploy image, and what it does under the hood, it will build the image again. It will tag it properly. It will also then push this image to the repository or at the factory. And then also you can see run the deploy command, because every time you make a change on the code, of course you also need to build a new image, and processing all the commands is quite heavy. And therefore with this deploy image short tag, with the help of image, we can make our life so much easier. So have a look also on the make image file. That's basically all I wanted to show you. Thank you for watching, and then see you in the next one. We covered a lot of ground today. We started by understanding why MCP matters, the real need for a standardized way to bring context into LLM apps. We explored the core architecture that makes it all work, dove into the transport layer that handles the communication, and then got our hands dirty by building a real MCP server with the help of FastMCP. Through our Technova example, you've seen firsthand how tools, resources, and prompts come together to solve a real business problem. The Model Context Protocol is still evolving, and what you learned today puts you in a great position to be part of growth. You have now the foundation to build your own integrations and contribute to this exciting ecosystem. And if you want to stay updated to the latest developments, make sure to subscribe my YouTube channel or follow me on Substack. I regularly share my insights and tutorials there. And if you have questions about anything we've covered today, please reach out to me on LinkedIn or drop a comment below. Thank you so much for watching, and I'm excited to see what you will build with MCP. So keep building and see you the next time. So I want to share some goodies that I discovered during my course, and the first one is Smilery AI. So every time you need to search or explore new MCP servers for your use case, Smilery is there to help you. You can use the search, but therefore you need to log in. I cannot do this, sorry, because then I would need my phone. But the idea is that you can easily search and then also get the information how to spin it up. For example, here Notion, you see then an overview. You can also go here to the GitHub to get more information. You see also the tools that this MCP server provides. So here all the tools, you can actually also then try it out here, very nice. And then they also provide their own CLI to really rapidly set it up on your machine as well. The next project is my own project that I want to share with you. Okay, shame on me to self-promote it here, but I think it's actually pretty nice. And here I also process AI agents with different technologies that you can also explore. For example, here a pretty nice one written in LangGraph, and from here you can also get then the documentation, the README, and also the use cases, the core technologies, and so on, the use cases, the architecture. And it's like Smilery, but for AI agents, and also here other as well MCP servers. So you could also use here my search to actually search for MCP servers. Here you would see then the browser management MCP server, how to set it up, and from there you can also go to the GitHub page. So also make sure to check out agent devs, and also I'm crawling here some nice jobs for you if you're looking for a job as an AI agent developer. And the last one that I recently discovered is MCP Jam, and this is a fork of the official MCP inspector that we also use in the course, but with some goodies in place. And you can spin it up very easily here with Docker Run. And the features are, where is it? Here the core features. For example, inspector supports all three protocols. This is very nice. Run the server tools with live parameter input, easily debug errors. We also have here a large language model integration, and the debugging is also much easier to do instead of the local global inspector. So these were the 3 goodies I wanted to share with you, and now we are really done with the course. Thank you.